Hi, science friends. Today we are talking about one of the coolest things ever, dry ice. That's right, dry ice. But dry? How is it dry? Well, you know the drill. Get your science apron, safety goggles, mom, dad, or another adult, and meet me back in the science lab. See you soon. Hi guys, are you ready to chill and learn about something cool? Okay, cool, because I brought dry ice to the lab today. Now we learned about states of matter, solid, liquids, and gas, and we learned about how water or H2O can change from a solid to a liquid or a liquid to a gas. But this is called dry ice, and it's called dry because it never melts. Never, ever. And it can never turn into a liquid because it's not frozen water. It's frozen gas. So if it doesn't melt, what is it doing? Well, you see all this gas? It's turning from a solid to a gas, which in science is called sublimating. Can you say sublimating? Good job. So when something turns from a solid to a gas, it sublimates. Whereas if something turns from a solid to a liquid, it melts. Great, we learned something new. So we want to have some fun with our dry ice. Let's go. Before we play with our dry ice, what kind of gas do you think our dry ice is made of? You already know this gas because we've talked about it in our previous lessons. It is called carbon dioxide gas. That's right, frozen carbon dioxide gas. And it is so cold that I have to wear protective gloves. It is 109 degrees below zero. That's so cold. Now, if we were to wear shorts and a tank top outside when it's snowing, do you think we would shiver? Yes, we would. So let's see. I'm going to introduce you to my friend, Q, the quarter. And I'm going to put Q in our frozen ice, and we're going to see if he shivers. Do you think he'll shiver? I think he might shiver. Let's see. Here we go. He's so cold, he's shivering. Let's see if his friends shiver too. Here we go. They're shivering! What's happening? Well, dry ice is so cold that everything else around it is like hot. And so the heat, remember energy, causes our dry ice to sublimate. And so on each side of our quarter, the gas is pushing it back and forth, and it makes it look like it's shivering, but it's hilarious, and I love it. Okay, that's so much fun. We'll let them warm up over here because they're frozen. Now, this is my friend Spoon, and Spoon loves to sing. And Spoon, do you think Spoon is warmer than our friend Dry Ice? Yes, of course. But I'm going to make Spoon even warmer. I'm going to breathe on it. Now, Spoon likes to sing, and we're going to see if Spoon can sing us a song. Will you sing us Twinkle, Twinkle, Little Star? Now, don't say anything. But Spoon has a terrible voice, but don't say anything. Just listen. Ready? Oh. Okay, so not so great. But why is it making that sound? Well, the metal is so warm that when it touches the dry ice, it makes that screeching sound. It didn't sound like Twinkle, Twinkle, Little Star, did it? No, it didn't. Should we try it again? Okay, let's try it again. Are you warm? Are you warm? Oh, not yet. I'm going to try to put her in some hot water. Here we go. I have some down here. Are you ready? Here we go. terrible. Would you feel that way if you had to sit on dry ice? I might scream too. Okay, good job, Spoon. Thank you for helping us out. Okay, now, have you ever put water in the freezer? I hope so, because in one of our last lessons, you were going to try to turn Molly the molecule water into a solid by freezing her, remember? And it took a while, right? Because even though our freezers are cold, it takes a while to turn our water into ice. But I want you to see how fast our dry ice can turn water into a solid. So I'm going to put a little bit of water into our friend Spoon, and we're going to see how fast it can turn water into ice. Are you ready? This is so cool. Here we go. Are you watching? It's getting cold. It's getting colder. It's turning into ice. It's doing it. It's happening right before our very eyes. Do you see it? It's so amazing. There it goes. Now that is cold. Now I want to see what happens if we add some warm water to our dry ice inside of our beaker. Are you ready? Okay. So I have some smaller pieces of dry ice. I'm going to go ahead and add them to our beaker. Now, how cold is it? 109 degrees below zero. So my room temperature water is probably very warm compared to that. Now, are you ready to hear what sublimation sounds like? Wow, look at that. Do you see that? So cool, right? Look at that. It's amazing. So carbon dioxide sounds a little bit like carbonation. I wonder if it tastes like carbonation. I'm going to try it. Let's see. It does. It tastes like soda water. Not sweet, just regular soda water. Pretty cool, right? Do you remember how we caught carbon dioxide gas with our glove and how we trapped it in our canister? Well, now I'm going to catch carbon dioxide gas inside of bubbles. How cool is that? Let's see if we can do it. Okay, I'm going to add a little more dry ice. I'm going to add a little more room temperature water. And then I'm going to add some soap. Let's see what happens. Here we go. Let's give it a little mix and see if it gets caught in our bubbles. Here it comes, here it comes, here it comes. Up, 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 up. Yes, we did it! Look it. It's inside the bubbles. Boop. Do you see this? Watch. Pretty cool, right? I love science. There goes the gas. There goes the gas. Pretty cool. I love it. Good job, guys. Now, I want to make lots of carbon dioxide gas, so I brought a huge bucket of hot water. Are you ready? I'm gonna pour in dry ice. We're gonna make a cloud, like in the movies. Here we go. Make a cloud. Here we go. Do you hear that? I love it. You can just keep adding more, and you're just up, up, up in the clouds. You can just keep having fun all day with dry ice. Well, until it sublimates away anyway. All right, that's all I have for you guys. Go have fun. See you next time.